Right. Hi, everyone. I'm Niall Ashley. I'm the chair for the 101 session today. This is the session is Modernize mainframe operations with the Red Hat Ansible automation platform. I won't dawdle. I won't waste too much time because there's a brilliant session to go ahead, and no one wants to be listening to my voice. Today we've got Fabio Alessandro Lacati, or Fale, as he's prefers to be referred to. So Fale is going to go through the session today. He has said if anyone has any questions, please post them in the chat, and he can answer them as we go rather than waiting until the end. But if you would prefer to wait till the end and we have any time, then we're more than happy to do that as well. So yeah, without further ado, Fale, I'll let you go ahead, and thank you for your time.
Thank you. So, hey everyone. Very quickly, I have been working in IT since 2004 in a lot of consulting roles mostly, and I have been an Ansible user since 2013, which was even before Red Hat actually bought Ansible, the company, Ansible Inc. And now I am an associate principal solution architect within Red Hat. And also I am certified for architect level 3. And I think that the part that I want to start with is a little bit about how I got into Ansible itself, because I think it's how many people actually get to Ansible. And I was in a company, was doing freelance consulting at the time, and they had this situation that was a little bit tricky because they had a bunch of people leaving, operation people leaving, and some issues with updates, and everything was kind of problematic. And then at a certain point, they had a huge issue with a critical system going down on a Monday, and they basically took 4 days to take it back online, which is not what you usually want to have in an operation situation. So their solution was, well, very easy. Let's fix this. Let's create a project to fix it. So the problem was that, as we were saying, the complexity was increasing. Some operation people left, and with that big issue, big downtime, the issue started to become fairly obvious that it was not working properly, the operation side of the house. So what was the solution? A project. In every company there is a problem, and a solution is creating a project. They decided to call it Project Diamond because everything is perfectly aligned in a diamond, and that was the idea of this project. So just to be clear, the goals of the project were reduce complexity, make every process explicit. So effectively, it's very easy to understand which part of the system does what, and what the single operation people actually are doing. It's very explicit. And third, avoid dependencies of a process to certain people. So effectively, if you map processes, usually you end up with a map of this person is going to do this, and then that, and then that, and then this other person does those things, and so on. But what they wanted to do is to move from that kind of process to a process where they can say an operation person, whoever, will do those steps, and then another person will do those other steps, but effectively without having specific names into the boxes, so that if that person is on leave or leaves the company, they have no issues on the process relying on a specific person. Now, the only problem with this project is that it did not really work. People started to call it Project Cool because obviously Cool has all the right components, but all the same components as the diamonds, but in a fairly different situation, organization, and therefore the result is very different. And why this did not work? First of all, the complexity increased over time. Every process was kind of explicit, but not really. And they avoided dependencies. So they were able to avoid dependencies of processes to certain people, but changing the process actually requires certain people. So they kind of solved the issue, but not completely, at least the third one, but the first two were completely missed. So why was this? The way they approached the project was to automate everything with mostly shell scripts, which means bash scripts for Linux, whatever Windows shell system there is for Windows. They use that, and they also use other Unix systems with other shell scripting systems there as well. Some networking scripting or automation, whatever. But in the end, they did not really create a strategy behind this. What they did was they just told to all the people within the operation side of the business, go automate stuff. And that is a little bit the issue that they had. So what they discovered was that, as I then changed a little bit and synthesized, but they discovered a fact that if you tell people to automate, or even if you don't tell people to automate, people will automate things when they meet a problem that they never want to solve again, which does not mean that they will try to automate everything. They will just try to automate the things that they don't want to do. And that is a little bit the issue with the automation if it's not properly organized. So anyone in an organization can automate some piece of work, but an enterprise needs way more than that to be able to coordinate and scale with the automation. So just to give you an example of a more abstract concept behind what happened there, is that you have a lot of different kind of people, and everyone has their own concerns. And if then you start to map people and processes, what you end up is with a grid. So the only way it can really work is if you are able to create a consistent governance across all the various topics that embraces all the processes. And that is how you break down silos and so on. And this is how I arrived to Ansible, because my situation was that I got started into this company within the first process of automation, the project Diamond that got renamed to Project Code by the people within it. But I had a very marginal influence in that project because I got onboarded to do the part of the project. And once we started to see that the project was not really going well, I had a conversation with the manager that was handling the project, and I was trying to understand why they went with that direction. And basically, his point was, we have not found any good solution, so we did create our own solution. And I started to look for a better solution, because I thought it was impossible that IT. It was 2013, but still, IT was a fairly structured kind of business, and a huge amount of companies surely have already found themselves in the same situation, wanting to automate stuff. So I was like, it's impossible that no one have created anything that is sensible. So obviously, I did encounter a bunch of other solutions, but then one night I was looking into forums or whatever the rules at the time, and this Ansible thing came out. And looking forward, looking more into this, I discovered that it had all the characteristics that I thought were correct to have. So before going exactly on the specifics, I want to introduce you to a concept which is idempotence. Hopefully, you have already heard about this, but probably in different concept. So the idea of idempotency is that idempotence is the property of certain operation in mathematics and computer science that can be applied, that allow an operation to be applied multiple times without changing the result beyond the initial application. So I know this is a little bit tricky as written in this way, but if you think about multiplying something by 1, so if I multiply 5 by 1, the result would be 5 again. And if I still multiply it by 1, so I reiterate the operation, the result will not change. And this is the case for a mathematics situation. Now, in IT, this can be applied, if you think about, in a situation, if we are able to describe the final state or the desired state that we want to achieve. So if I say I want to have a file named home in this specific folder, if the file is there, perfect. If the file is not there, the file gets created, but then at the following run, also the file would be there, and therefore no changes would be done. So this is the concept of idempotence. And as we'll see, Ansible is heavily based on this concept. So why Ansible? First of all, it is open source. It's fully open source. It was at the time, it is now. Also now, well, at the time you could buy Ansible Premium, I think it was called at the time, from Ansible Inc. Now you can buy Ansible Automation Platform from Reddit, but that is a support thing. You can do whatever you do with the open source version with the proprietary one and so on. And it's mainly based on push mode. So there are multiple ways of doing automation I've discovered, and the two most common ones are the push and the pull, or agent-based. The agent-based, like Puppet, for instance, is an example of this. You do install a software, an agent, on every host that you want to handle, to manage. And what that agent will do is pull the configuration that you are expecting for that host and apply those configuration on the host itself. And in the other hand, we have the push model, or agentless, which basically has a host that is the controller that will push configuration to all hosts. So effectively, the host that will receive the configuration, or will need to be configured, does not require any changes from what you would do in a human-based configuration system. So this allows a more simple system and also more secure, because basically you will secure that connection, which for Unix cases is SSH, in the same way you would secure it, if a human was to use it to configure the host. Another big advantage of Ansible is that Ansible does not describe how to do things. So when you write a playbook for Ansible, a bunch of code for Ansible to ensure that it configures properly machine, you will not explain Ansible how to do it. You will explain what is the desired state that you want to have. And this has two big advantages. One of the is the simplicity, so that effectively you will have a simple YAML file in this case, but still a file that will describe a state, which is much more easier to understand and handle than basically a program that will the output of that program will be the state of the machine. And also, it's basically just putting the data that is the state that describe the state, rather than the code that creates that state. And as we were saying, one of the consequences of this is that it does have a way smoother and gentle learning curve, because you just need to understand how to describe a state in a way that Ansible understands it, instead of creating code or learning a specific language and so on. Another consequence of this is that the code ends up being very readable, because it's basically a description, and you don't have to remember what is the state of the variables or that kind of things. That is usually how it works if you are reading code, a real programming language code. We also have this concept of collections. At the time it was roles, but now they are more structured into collections. That is a mechanism to allow code reuse, which always helps if you want to automate a lot of different things that are still related, like different aspects within a company, or maybe you have to automate a lot of tasks for a bunch of mainframes. You will have some of the aspects that will be different in every task, because of the, if not, there would not be different tasks, but still you will have a lot of similar or same parts that you can reuse from one process to the other. And another big advantage is the ecosystem that is very strong due to all those aspects. So speaking about Ansible itself, there are a few concepts that are very important in the way that make Ansible work the way it works. The first one is the idea of a host. A host is the target of the automation. So in the situation where you have one system a controller that manages multiple other machines, those multiple other machines would be the host. Another concept is the concept of group, which basically is just a group of hosts. The reason why this is so important is that in Ansible, we don't usually think in terms of hosts, but in terms of groups of hosts, because very often you will have more than one machine doing a specific task. This is either due to scalability issues or HA or other reasons. Now, this does not always apply. And in case that you have only one machine that does a specific task, it's enough if you create a group of one, and it works properly as well. The concept of groups and hosts is then within the inventory. And the point of the inventory is that it's a collection of hosts and groups of hosts. The reason why inventories are important is that it allows you to basically decouple the machines that you are going to operate on with what you are going to do. So the process from the targets. There is then the concept of module. A module is usually a Python file, but it could be potentially other kind of files, which are effectively programs. The good part is that you don't really see them. You only use their interfaces, because those are all modules are structured in a way that they will get a bunch of inputs, and they will get you back a bunch of outputs. And in the meantime, they will ensure that they will operate on the target systems, target hosts, and ensure that the state that is described within the inputs is enforced on those hosts. And there is then the task. An Ansible task is basically the name of a module and all the inputs that it's going to be passed to that module. And the idea is that then you can add multiple tasks, so effectively multiple instantiation of modules with specific inputs all together in what we call a role, which is an abstract collection of tasks, basically. And those are usually, or better saying, they should be idempotent, because the module itself is idempotent. So the task, obviously, since it's just a module with parameters, is still idempotent. With roles, you can, in theory, create roles that are not idempotent. If you, for instance, create in the first module a file, and then in the second one, you delete it, obviously that would not be idempotent. But that is not how you should be doing those. And then we have the concept of playbook, which is a mix of multiple tasks and roles. So just to give you an example, we might have the role of deploying or ensuring that it's deployed, ensuring that an HTTPD server is deployed, Apache HTTPD, for instance, or whatever other web server you want to use. And a playbook can be using that base role of ensuring an HTTPD server is deployed, as well as adding maybe the files that server will need to serve. So with this, you can create basically a more complex process. There is then the concept of collection that we have seen, where we can package and redistribute multiple modules, roles within the same package, basically, so that, for instance, if you are a hardware vendor or software vendor, let's say, for instance, IBM, IBM can say, okay, we have created 1,000 modules for mainframes, on how to handle mainframes, how to manage mainframes, and some roles as well, with some best practices or stuff like that. And we are going to package them all together and ship them as a collection, so that basically all mainframe users can simply take this collection and leverage all our work for their automation. And to finish those concepts, there is the idea of execution environment, which basically is a container in the sense of like OCI container, Docker container, whatever you want to call it, that contains the Ansible executable, all the collection that you want, all the needed library. In this way, you can be sure that the version of those collections or Ansible or libraries will not change over the course of your automation. And just to go a little bit further on a couple of those, inventories, for instance, the reason why it's so important that they are splitted is because they can be of two kinds. One is the static inventory, which basically is a file. It could be a JSON file, YAML file, whatever. But it's basically a list of all hosts and groups and variables that you have for that run. But those can also be dynamic. So effectively, you can create your own script or use someone else's scripts to extract those information from SAMDB or any other kind of software. And the idea here is that you can then automate a lot better if you automate in a way that is abstract to that specific machine, because this allows you to, over time, maybe increase the number, the instances, for instance, of your host without having to change your logics, your automation logics. And just to give you a few examples on those dynamic inventories. All the clouds have their own. Also, you can write your own as well, and every CMDB can provide one. And just to give you an idea of what exactly this Ansible code is that we have discussed so far, this is an example. So in this case, this is a playbook. So this is something that we can effectively run as or provide as an input to an Ansible run. And as you can see, we have the host all, the second line, first line after the initial dash 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 that delimits the beginning of a YAML file. And that means that this will be run on every host. Effectively, all hosts that are within the inventory that is provided become true, means that we are going to do a privilege escalation, which if we are running on a Unix machine, or better, on a Linux machine, this would be sudo. On other kind of Unix machines, every Unix machine have their own, every Unix OS have their own way to do privilege escalation. And effectively, what it will be done is that Ansible himself will understand on which machine the playbook is running, and based on that, we'll do the proper way of doing escalation there. And then we have some tasks. And the first one has a name, but this is just a label for humans. Ensure HTTPD is installed. And then it does have a name of the module that is invoking, yum in this case, and a couple of parameters, name and state. And as you can see, the second one is pretty much the same, but it calls a different name, a different module, because it's the service module, which allows us to handle services as of services that start at boot or not. And as you can see in this case, this is idempotent, because the first one will ensure that HTTPD is at the latest version. And if it's already there, it will be skipped. While the second one will just ensure that HTTPD is started at boot time. And if it's already set to be started, then obviously nothing would be done. And as you can imagine, also you can have way more than just two tasks, but it's basically would be similar concept, but just a longer list and with more parameters. So collections, I think those are very interesting because they can shape a lot of different things, such as module, playbooks, roles, plugins, documentation, tests, and so on. And an instance of this is are actually the IBM ones for ZOS. So all of those are 13 collections. And as you can see, those are for, let's say, specific groups of operations. The reason why IBM decided to split those collections into multiple collections and not create just a big one, I think it's related to the fact that whoever created those thinks that it's very rare that the same person or the same company will need all of those. So it's easier to handle and to package, and also to develop as well as multiple smaller collections. But you can basically go here, which is the galaxy.ansible.com website, and you can see all the collections that you can use, and also you can create your own. But if you reuse some collection that have been created by someone else, such as IBM, also you will have all the knowledge that that organization put it into the collection without having to write your own. So just to give you a couple of examples of numbers around Ansible, We are talking about 2 million downloads per month with 2,000 customer for the Red Hat version, and 4 million systems managed. And consider that all of those are only for the Red Hat version, and this is obviously due to the fact that Red Hat knows how many customers they have, but it's not possible to say how many companies or people are using the open source version, which is open source, and therefore people can just download it, use it, not use it, or maybe use it for 1,000 machines or 1 million machines, no one knows. And just to give you an idea, there are roughly 4,000 modules in the core part of, so in the core collections, plus a few tens of thousands in additional collection that are from third parties. And it's also the 7th project on GitHub based on the number of contributors. So what makes Ansible automation platform a platform? The idea is that there are multiple ways of defining what a platform is. I personally use a model, and in Red Hat we have also adopted this model, which splits the automation in 3 different steps: create, operate, and consume. And the idea here is that when you do the automation, whatever part of the automation you are into, you will probably, I think it's very functional to think in this way, because you will have someone that creates the automation playbooks or the automation code, if you are not using Ansible. Then there will be someone that operates it, so effectively ensures that it's running and gets run properly, and all the other things that operation usually do. And then there is someone that consumes it, in the sense that someone that wants to have something, they don't really care how it works, they just care to have what they were looking for. And an example of this would be someone that just wants a VM. They don't care how a VM gets created. That is not their job. They want a VM. And therefore, they will be a user of an automation system, because maybe in your organization, you will have to click somewhere on a dashboard or ServiceNow, whatever. And if you click there, you will have your VM provisioned. And the idea is that you can use this pattern of thinking to think, does this make sense for everyone else, and where am I into this whole automation process? So starting from the create, in the Ansible case, we have those 3 components, which are the collections that are maybe third parties or you have created your own. There are a bunch of dependencies probably that are required by those collections. And then there is the runtime, so the Ansible version effectively. And all of this gets packaged into that execution environment that we mentioned before, with UBI on the bottom. UBI is like a very basic Red Hat Enterprise Linux version that only contains the more core packages, so that effectively you have a reasonably small container, and that is still certifiable and testable and reusable. And the way that Ansible provides all the tooling around the automation is because we have also a content creator, which in this case will not be doing videos or other things on social medias, but will create playbooks and roles. We then have an execution environment builder, which is a tool, a command line tool that it's provided within Ansible to create those execution environments. Then also we do have the execution environment, and then we have the private automation hub, which is another component of Ansible, where basically is a registry where you can push your execution environments to. We also have the content creator that will produce the playbooks and those kind of more leaf part of the automation. So effectively roles and playbooks would be the most common ones. And they will use the automation content navigator to navigate the execution environment list, as well as eventually to then push their work so that everything is there, is stored, can be tested, and can be validated as well. So from the operation standpoint, you have the execution environment that got pushed into the system, and the playbooks that got also pushed into the system. But then you also need to create or use or have all the things around to make it effectively highly usable. So for instance, you will need to have APIs or webhooks to integrate the automation, the Ansible automation parts with ServiceNow, for instance, for ticketing, or maybe some approval system within the company, or some other tools that will make sense to be able to trigger by Ansible, or vice versa, to trigger Ansible. And also we have the concept of workflows, because sometimes you might have multiple playbooks to be run one after the other to complete a more complex task. So for instance, if I go to ServiceNow and require a VM, that is probably a playbook somewhere there that will create a VM for me. But if in my ServiceNow I can say, oh, I want a VM, but with MySQL or DB2 installed into it, then obviously those will be two different operations, one to create a VM and then one to install DB2. And the way that we can do this with Ansible is with a workflow, where basically we can stack together multiple playbooks to create more complex scenarios, but that are still very reusable, because maybe we do have multiple different playbooks for creating a machine, because I might want a machine created in the method A or method B, method C, but still the method of installing DB2 would be the same for all of them. So I can split them and reuse the code. And then also you also want to have all the credentials managed, so synchronization with Active Directory, LDAP, whatever, as well as all the logging and auditing trails. As for the consumer, you would not really care too much about what happens there. The only thing you care is a web UI or API. I mean, you don't care about the API, you would care about the portal that is in front of the APIs and communicating with the APIs. But you just see this, and then all the rest, the control plane, the execution plane, and also the system themselves are completely hidden from you. And you simply, use them and leverage the whatever it created for you, VMs, configurations, or maybe the creation of new user on specific boxes, or the removal of users from boxes, and so on and so forth. So to wrap up a little bit this presentation, first of all, automation is the key to simplify and optimize IT operations. I think this is nowadays an accepted truth, probably throughout the industry. I know that some companies are still not maybe doing it, but they know that automation is the way, even if it's not always the easiest thing to start doing. Second, a single automation platform can provide way more value than trying to automate in an uncohesive way. Third, an automation system to be called a platform requires way more things than just the automation tool itself, because it requires all the other aspects that control and support throughout the whole life cycle of the automation itself. And fourth, also Ansible, at least personally, I think it's the most complete system for an automation, and has a full ecosystem of partners that also provide content for it. So with this, thank you. This is also the feedback forum. And I don't know if there are any questions.
Yeah, if anyone has any questions, we can, we can either unmute you, or in fact, I'll set it now so that the audience can unmute. There you go. So if anyone's got any questions, feel free to unmute and ask, or you can post them in the chat. Fabio, Fale, thank you very much for your session. As you've just said, please, to everyone who attended, if you can submit feedback, that will be done through the link that he's put on screen share there, or you could use the QR code if you want to scan that with your phone, or you can use the link that I've posted in the chat. It's session 6H. The feedback is very valuable to GSE as an organization. It allows us to work out, whether we're fulfilling everything that our audience want, and it allows the speakers, the presenters, to work out areas of improvement. Not that I think that session didn't need any improvement, but I'm biased because I helped choose it. So thank you to everyone for attending, and if there's no questions, which thanks, thank you, Adrian. Yeah, he's just said thank you, Fale. If there's no questions, feel free to sort of, I assume, head off and get your lunch. I'm assuming it's about lunchtime for you guys as well. I will. What I'll do is I'll leave just in case anyone doesn't want to ask any questions in front of me for whatever reason. I know I can be quite intimidating, but if Fale's more than happy to answer the questions. But otherwise, have a good lunch, and hopefully see you in the next session at 2 o'clock. Thank you very much, everyone.
Thank you.